Next up, we have our very own Phil Edholm. This is his final segment in his scratch building a NMRA contest winner, national winner. He utilized 3D printing and acrylic. So I think we're going to get into the acrylic part tonight. Is that right, Phil?
No, actually, we're going to finish the 3D part. We actually did the acrylic part earlier. It was fairly short there earlier. So what I'm going to do, we ended last time with talking a little bit about the roof. So, I got done building the building, started looking at doing the roof, and what I came to the conclusion was you could do a roof as a series of pieces. So if you look here up the upper right, that's actually one piece. That would be one of the back pieces on the sides. The front, actually, if you look at it, is actually 5 or 6 pieces. So there are 2 big pieces, and then there are the 2 angle pieces of the main roof, then the 2 angle pieces of the subroof. And those were all aligned so where they join up, would line up and could be glued together. So in the end, the roof all glued up. You're seeing it being clipped together and glued there at the bottom. The roof was finished basically the same way as the rest of the building. That was done using again the caramel paint and dry brushing. And these were just some assembly photos of it. You see on the right side there, the ceiling on it. The ceiling was done using the Northeastern O siding. So Northeastern sells 2 kinds of O siding. They sell a corrugated siding and a wider banded siding. So the way the siding was done is you cut the siding into pieces. You see that being done at the upper right using a square and cutting them into specific pieces. I think these were 10 by 3 or 10 by 4. Then those are secured to a piece of wood with some masking tape, painted with fairly light gray primer. I looked around and found light gray primer. You kind of see that on the sawhorse, them, they're all being painted. And then using Dr. Ben's rust, put rust on them. And the beauty is this way you can rust them individually and at one end only. If you try to do it after the roof's done, you get something that doesn't look very natural because rust doesn't rust in splotches on the roof, and it rusts on individual boards. So that's basically the way the roof was put together. Then at the edge of that, put in a trim board because that actually, from the side, you don't see any of the 3D printed pieces underneath it. So just very simply dry brushed it, then added in the siding. One of the things is the non-corrugated, the other siding, which is I can't remember the name of it now. Actually take that siding and cut it, and it has a single groove. It has grooves that are about 9-10 inches apart in O scale. And if you cut on either side of those, you can get a piece that can be bent. And so that's actually what you see there is the valleys. So the valleys get installed and then the corrugated, and they just get glued on. I used pretty much canopy glue for this exclusively. Glued them on, just held them down with weights as they glued on. You can see that I did all this assembly work on that acrylic structure that I originally built. So it actually became a framework to put those things together. So this is kind of some views of the roof. And then again, using that seam siding as the top on the roof, as the top corner there. So just a couple of other pictures here of things. What's going on here? There we go. Oh, my slides jumped on me there. I'm having jumping problems here. So just a couple of views. You see the lower left, the interior truss hasn't been put in place. So you don't see you see the hole there for the truss, but you actually don't see the truss. So the next thing was the doors. So I have to admit, on the doors, the smaller doors for the building that were fixed doors, I actually kind of wussed out on that. I wimped out. Instead of trying to make them as hung doors that actually would open in and out, I actually made them fixed. So those were actually built just as individual pieces of wood glued to the angled supports, some brass wire for hinges, and just glued in place. The reason was I found after I built the previous building and had the removable doors, when I took it off the layout and put it in a box, I ended up having to reattach half the doors, and I figured having all these doors to reattach would be a bit much. But for the back of the building, I decided to do sliding doors. And the reason for that, obviously, is the track is very close to the building. There's not really a loading dock. There's not really a place for swinging doors. And inside the building, there's a fairly narrow platform that's at the raised elevation of the rail cars. And so having a swing in door really wouldn't work very well. So what you see at the left are the pieces. The way that was done was actually building a carrier which was printed as 1 millimeter thick printing on an FDM filament printer. Then printing it on the upper piece there, you can see as a slider where the doors were going to slide in, and then the doors were covered with wood and trim. So basically, this is how the pieces came together. You can kind of see that that channel at the top had holes in it. If you look on the bottom there, bottom right, you can see each of the doors has two little pieces molded in the top that have a hole through them. I was at my local hobby shop, and in the model airplane part of the hobby shop, they had some carbon fiber rods that they use in model airplanes. And I found if you actually use those as the slider for this versus a brass rod, the doors slide amazingly smoothly. So what you kind of see is the bottom, the inside. Again, these were finished, stained, and then dry brush painted. The next thing I had to do was this was a sugar warehouse, so I needed to put some sugar cubes, some sugar sacks in it. So I decided to do that by taking the Grant Line sugar sacks. They have a package of these, and actually molding a lot of sugar bags. I think I molded, if you see the bag up there on the upper right and the left photo on the right of it, I think I probably molded about 1,000 or 2,000 sugar sacks. And the idea was that those would be glued onto this frame that was 3D printed as a couple of pieces. So instead of trying to build everything as sugar sacks, kind of built a framework to cover it. As I built this, what I realized was I hadn't anticipated how you get sacks onto the top of it. So what I did was added on a ramp where you could actually load the sugar stacks up on it. And then I realized that doing the sides was going to be a challenge. So what I did was bought another batch of sugar sacks from Tishy and actually ACC'd those together into a stack, as you see in the upper left, and created again a few molds for that and molded those stacks that go on the sides as individual pieces. So each one of those stack of sacks is actually molded or printed, whatever you want to call it, into a single piece and then added on. So that actually generated what were the sugar sacks inside. So essentially, that's what how the buildings were built. I think I went through everything pretty well. These are some pictures of the inside. You see the sugar sacks after they were all painted and weathered weathered primarily with some chalks and some washes to finish them. One of the things I had to do is figure out how to move the sugar stacks up. And since I couldn't find anything in any real good way to do it, came up with the idea of making these wooden plates that you could roll a hand truck up with sugar sacks on it. So you actually have one of the workers rolling a bag of sugar stacks up. Finished the office. The office has some, I think I can't remember there's a desk in there and some chairs and things that I bought. So this is kind of, again, a view, I think you've seen this before, of the overall structure. You can see the sugar stack loading there because they need different pieces depending upon how tall they go. There's an extra piece there. You can see kind of on the floor in the middle. There are some wooden barrels on a 3D printed barrel holder because clearly you have to have beer for the workers working at the sugar beet refinery. And the stack of pallets actually, or stack of crates there in the kind of middle bottom are actually being shipped to the sugar processing facility. So just a few kind of more shots of the inside. So I want to close with the final building that I built using kind of these techniques. On this module, there's a wharf that's built based on the Standard Oil wharf that was in Monterey. So in Monterey, they had a big pier that went out, and they actually had kind of off the pier, think about an L going off the pier, they had this Standard Oil wharf. And so I decided I wanted to have a wharf. I wanted to build some of the ships that you can get from Frenchman's River. You can see one there. That was actually one of their ships What I found was that all the ships, all of the fishing boats out of Monterey had fly bridges. So you can see I've added a fly bridge onto it. It's not painted yet, but kind of coming together in this picture. What I found was there were a huge number of pictures of this pier. These are actually prototype photos. It turns out that most of the folks in Monterey that were fishermen were actually Sicilian, and they would have family days where they would take the family out on the boat. And it turned out the way this pier was, that it was kind of an L. There was an ideal place for a cameraman to set up and take pictures of the boats with the families on them. So that gave me a whole bunch of photos of the prototype to be able to use. So then I used that to design, and you can see from the pictures, it's slightly condensed and compressed to actually design and build this little building that goes on the pier. Having done the 3D printing on the warehouse and understanding construction techniques, this time I decided to try to make it a little bit more realistic. So if you notice, and the picture really kind of look at is the one on the bottom right, if you notice the walls, there's actually a gap between the studs and the aluminum framing. So if you look at the wall, it actually has three different layers, which is what you typically see in construction. There are the vertical studs that support the structure. There are the angled braces that provide the shear strength to the structure. And then there are furring strips that are on the outside of the studs that the vertical siding gets nailed to. So what I actually did was created those as three different layers. So when you look down into the building, you actually see that depth between the different pieces. Um, so the way that was done, and then the roof, this is the roof assembly. The roof was actually made again as a series of 3D printed elements, and it can just be picked up off the roof and put back in place. This picture was taken before the lighting was put in that you saw in the previous picture. So the way this was done was if you look on the upper left, you kind of see all the pieces. So what you have for each wall is you have the actual wall framing, which is the vertical, and then those angles for the shear bracing. Those were printed as a single piece, and then for each wall there was another piece, which you see there, the one the far left. You see those with the horizontal boards. Those were actually printed using the same template. Because one of the beauties of designing this stuff in CAD is once you've designed something, you can use that as a template to be able to start another design. So it's really easy to make both of these and make them fit. So essentially, those were all finished separate from each other. And you see in kind of the right middle, you see the pieces of the roof. You can see the two pieces that have the joists that run across the roof, and then what's essentially the trusses for the roof. The sign itself was printed as two different pieces and glued together. It turns out when you want to print something in filament printing and you want elevation in it, it's very hard to print something that has detail like that on both sides, because the side that's down to the printer, you have to have supports and it doesn't turn out as well. If you cut those in half, print them as two pieces, then glue them together, you can get that detail on both sides. So essentially those were, just clipped together into a frame. You can see that at the bottom left. You can see as it's glued together. They were painted before they were assembled. You see kind of in the middle there was a light bar designed with some brass rods to hold in place. And at the far right on the bottom, one of the things that I had as a challenge was trying to get the roof built. So I actually designed a little 3D printed cradle that would hold all the roof pieces while they were glued together. The floor was just very simply some boards glued to an underlying frame. No reason to 3D print that. So, looking down at the building, I really like the detail you're able to get in a small structure like this. And I think the lighting actually looks pretty reasonable. It doesn't look like it couldn't exist having been done like that. The light fixtures here are basically 3D printed with just a little micro LED inside, one of those, I don't know, 2060, whatever they are, they're very small LEDs. The tools there actually were some produced by the Fast Tracks folks, Mount Albert. They actually produced some laser cut tools that I bought at one of the narrow gauge conventions. What I really like about it is when you look through the windows, it looks very realistic. Looks like it could actually be a real building. Final point of this for those of you who are looking at this and say, well, I'm in HO or I want to model something other than a building that has large framing. I actually did some small wall sections. So what I did was I designed in CAD what would be a 2x4 wall section. Um, One of the things you'll notice on this is I actually did this the same way the last building was done. The diagonals that are actually for support were molded into the structure. If I go back, I'm going to go back one slide actually here. Back here, if you notice these on this slide, those diagonals, the shear diagonals, were actually molded on top of the framing. When I printed those were printed on top. So when those printed, they actually print with supports underneath them. One of the things I found is it's really easy to pull those supports off. And because the supports are on the backside of the wood, you don't see anything that supports leaves on the backside of the print. So it actually looks pretty good. These over here were actually done the same way as I did the warehouse. They're actually molded in. But then I actually printed those as O scale and HO scale so these are 2x4 standard 18-inch framing for a wall. And when you print them out, they actually come out pretty good. What you see is on the left there, that's the O scale one. On the right is the HO one. So you can actually do this in HO or O scale. Um, Finally, just a few learnings and regrets. You can make the sections smaller than you think. They actually works pretty well. I'm constantly amazed at how well the 3D printer works. You could actually even cut it down if you had been doing really small sections and use a 0.3 or even a 0.2 nozzle head for your printer. The gray and lighter filament works best for this. It seems to me that the gray has a minimal amount of additives to it and actually prints better than, say, a black or any colored filament. We talked about printing flat, smaller sections down. The hidden supports work good. So if you put the diagonals on top of the wall and print it with those up, they'll get supports underneath them, but they're really easy to pop off. And you never see the backside because it's against the outside of the wall. The side grain works really good for looking like wood. One thing I found as just a hint, if you have something that when it gets done printing is not quite straight, don't put it in the oven thinking that 135 degrees in the oven will let you smooth it out. If you look in the middle of those parts over on the right there, there's a lot of test prints. The one in the middle there that's kind of wavy, that was actually a roof section that I tried to straighten in the oven. What I have found subsequent to this is that if you have an issue with the print, I 3D printed an O scale re-railer tool, and the fingers on the re-railer tool were a little off. They weren't quite straight and flat. And what I found is if you get a bucket and put it under really hot water, our hot water heater is pretty reasonably warm. Get a bucket of hot water, you put the print in it, just hold it in it so it warms up a little bit, and you can actually straighten out and hold it straight. So hot water is a pretty good way to manipulate a filament print and actually make it better. You will have a lot of prints. Think I probably threw away a kilogram of print material doing this. The filler primer is most important on those visible surfaces. Dry brushing is really important. I think dry brushing is an incredibly important skill to learn for us model railroaders because it really does let you create that look of partially painted things. The other thing, like I said before, the semi-gloss didn't matter after you dry brush it. So when you go looking for a base color paint, if you can't find a paint in anything except semi-gloss, if you're going to do dry brushing on top of it, you probably don't need to worry about it being glossy. Some changes, I would have liked to rethink the way the base floor mounting was done. Epoxying directly down to the masonite while it worked had some disadvantages. The boards on the wall that go below either the 3D print or the acrylic are actually onto the masonite, and that actually became a little bit of a challenge to get that to look right. I think you could be a lot more accurate. I added on a millimeter to most of my window dimensions. So most of my windows were Tichy windows. I measured them, but when I did in the 3D in the CAD design, I actually added a little bit of spacing to make sure things would fit. The reality is that those windows are exact, they're all exactly the same. And the 3D print is almost exactly the same. So you can be very accurate and have things fit very tight if you want to. I would have made the roof members smaller. When I got done with it, I thought they were a little large. But quite frankly, the level of effort to go back and redo that and the CAD system I was using was going to be fairly large, since it was actually, in the end, was about 12 different parts. Um, I would have liked to have a little bit better way of doing the wiring. The trusses that have the lights in them are not removable. They're actually soldered together and kind of daisy chained. It would have been nice to figure out how to put those on a plug and make them removable. So if you really wanted to do things in the interior, you could. On the other hand, you can remove about half of the trusses. So that lets you get into the inside if you need to re-glue things down that break off, etc. And the last thing is I probably would either reprint the gusset plates that I did in 1 millimeter instead. I think I used 1.2 or 0.12 millimeter height, or actually do them in resin. So that brings me to the end of how those buildings were built. So back to you, Tom.
Oh, that was a great four-part series, and I think it's clear to everybody why you took place in the national con with that. Really some
Cool.
fantastic modeling. So in addition to your production skills at New Tracks Live, you're a great modeler, and we thank you for sharing
Thanks.
that series.